Hi everyone, welcome to our 13th, lucky 13, plasma call. Today we are missing our great Joseph Poon. It's very sad. Yes, everyone. But we still are gonna have, I guess, a couple discussions. We'll see how long it goes. Anyway, who wants to kick it off? I'm hearing Gnosis.
Yeah. Yeah, hey guys. Very happy to finally be on this call. We've been working for a while already on our own specification for Plasma. So already like over 1 year ago, we were thinking about how we can come up with better market mechanisms. I think all of us, we see that there are more and more tokens being created. Eventually there will be millions of tokens for all kind of assets. Blockchain allows us to create tokens for tokenize almost everything at some point, hopefully. And that's why we have to come up with better market mechanisms to allow efficient trading of those beyond just order books. And yeah, we also, of course, have to have some infrastructure that allows us to actually scale this. And we found Plasma to be the best fit for this. And that's why within the last couple of months, we've been working on our own specification. I think around 3 weeks ago, we finally published the first version of our paper. And yeah, I think Alex from our team, I maybe just introduce everyone from our team. So there's Alex, who has been mostly working on the paper. Recently, Felix joined us, working on the implementation together with Ben. And yeah, I think Alex will later in the call give a short presentation about our progress. And yeah, excited for your feedback. And I'm CTO of Gnosis.
Cool. Exciting. Any other updates from other peeps? Calvin, you're smiling.
Oh no, I was smiling at the keyboard clacking. Minor minor updates. Learn Plasma is getting there. I'm trying to update it as I have time. If anybody here wants to contribute to that, let me know. A lot of different pieces need contributions. So, or if you have ideas for things that you want to put on the website, just go ahead and make a GitHub issue and I'll get to that.
Calvin, can you post a link just to the chat, because I'm on the street and constantly muting myself. So just I will save it and maybe have a look later. Just post it for everyone if you can.
Yeah.
Oh, okay. Yeah, I see, Georges. Thanks. Maybe I can say a little bit about what we did these 2 weeks. I'm on vacation, so I was trying to. I sent a mail to Georges and Ben about Plasma Debit, what we can do, how we can implement, and what will be an initial capacity problem. I also linked one simple slide, but the problem with Plasma Debit is we need some initial capacity. So first, 2 people who deposited Plasma Debit cannot transact between themselves since their capacity is the maximum. So we need to somehow provide some initial capacity for people. Otherwise, I finally found a person who works in a client for more viable Plasma. So I don't have to do it all by myself. And finally, I hope we can post it in a week or 2 for a verifying client.
Right, so the problem in this case is that we don't have a way to like start emptying out a coin to have a capacity to have channels throughout the users. This is what you were referring to, right?
Yeah, that's exactly the problem. For now, I only see one option as an operator makes a security deposit of some substantial amount and make some empty coins with some capacity for the same amount.
Yeah, that's right. And I think I wouldn't think of it necessarily as a security deposit, but this is just basically sort of part of the nature of how Plasma Debit is designed. Right? Is that with those to have extra capacity, the operator needs to have. It's basically money that's held by the operator. And so just in the same way that like a Lightning or a Raiden style payment channel network requires hubs to put down sort of a substantial capital requirement in order to provide liquidity for other parties to transact, the operator needs to do that in this at least in sort of the simplest form of Plasma Debit, where the operator is sort of the counterparty on every channel or coin, however you want to call it. Then yes, so you end up basically so the operator could do that by creating a bunch of empty coins and allowing people to sort of transferring that to them and giving them some of the value when they deposit. That's one way to do it.
What would we want to make the conditions to mint empty coins, and how should we choose the capacity of each coin? Because like we said in a previous call, I imagine that coins that are larger, they have more use, like bigger collateral and payment channels.
So you mean as like an optimization problem?
No, like literally what is the rule for minting a coin?
It's
an empty coin.
Yep, the operator makes a deposit. So what happens is if the operator deposits money in, they can create a coin that's empty, and an empty coin in sort of Plasma Debit rules is a coin that is entirely owned by the operator. It's one where the balance of like the user is zero. So then, they can then sort of transfer that zero balance coin to anyone without giving them actually any money. They just now have an empty coin on which they can receive money. So you can think of it basically as if you can do maybe the simplest way is that whenever anyone creates a coin, they can optionally specify, by the way, I only want the user that I'm depositing it to have like this portion, this amount of it. Like if it's like they're depositing 5 ETH, they're like, I'm only depositing with a balance of 3 ETH. So the other 2 ETH is going to the operator. So you can do it with, now I'm depositing 5 ETH, balance of 0 ETH. That's an empty coin.
This is interesting because we can use it like to have like in entrance fees. So if an operator wants to impose some like, you can only join my chain if you deposit 2 Ether, for example. They can just say mint a coin and give me 2/5 or whatever amount.
Right, and in fact, a payment to the operator is a very efficient way to do that, and a way to get it, started with you having some capacity rather than you just having just sort of like a send only channel, basically. Absolutely. So I think so if the operator wanted to front load fees and just said like for the entire lifetime of your channel, all you have to do is pay upfront for this sort of portion of it. And that's a way that you can get sort of free capacity there.
Okay.
This is a good topic, since an easy option for fees is just prepay everything up front for the lifetime. But in the case if operator wants to take some fee per transaction, we have a problem with accounting of all these fees. For example, operator later wants to take these fees and move those to the mainnet. It's very global part of the state, and since it's global state, it's very difficult to operate on it and prove that you actually have enough.
I don't think it's global state. It's local to every coin. How much of it is owned by the operator and how much is owned by the coin holder. And so you can, if the operator needs a piece of that, they could withdraw from only one coin and say, I'm withdrawing the operator's portion from this coin. Now they got to wait the normal amount, whatever, a week to actually withdraw it because they need to leave room for challenges. But it doesn't require any sort of additional logic. There's no sort of global state for the operator here. It's still all just, they own a bit of every coin. They own like,
but in this case, the user which holds an interest of having the coin of large capacity, his rights are on stake. It's like, well, I have a coin which is 1 ETH right now, but the maximum capacity is 100, which is great for me. If an operator wants to withdraw from it, he partially takes some, non-physical, but some interest from the user.
That's a good point. And in fact, you're right. And we were talking maybe last time about the idea of like markets in liquidity, like buying a coin that has more receiving power. And you're right. If the operator is able to just withdraw that at any time, that's arguably, I appreciate that. That's a very good point. So I'm not sure where you want to draw the line there, like whether you want the operator to be sort of forced to maintain that liquidity, or if you want the user to ultimately sort of be for anything that all the liquidity hold is just sort of ultimately at the mercy of the operator. But yeah, I think we can look to. I think the best way to think about Plasma Debit generally is sort of coming at it from the perspective of like Lightning or Raiden or another payment channel network, rather than from the perspective of like Plasma, and saying like, So like, and this is a trade-off I think that they have to handle a lot, is dealing with like how do you sort of purchase liquidity? How do you like who's going to provide that? How do you charge for liquidity? And given that, right, if you charge for liquidity by saying like it's going to cost this much for you to get this coin with a lot of receiving capacity, and then the operator can just I'm plonk withdrawing that all. That's that's
But that's okay.
Sorry,
that's okay.
Maybe
this is. I imagine that any kind of like how the coordination between payments happens is going to be like a Plasma app built on top of it. So it really shouldn't be like part of the core protocol.
No, but if the operator ultimately owns all the liquidity, if they can at any point withdraw their liquidity, then a second layer market in liquidity and like I'm going to get a coin with a lot of receiving capacity is kind of it's on uneasy ground. It's not a sort of safe thing to do to purchase. Like I was like, oh, fantastic! Now I have this coin I'm going to be able to receive Ether on this Plasma chain for the rest of my life. It's like no, ultimately it's like the Fifth Amendment and just take all your liquidity. You own your coins. Yeah, and maybe you could get more complicated. You could say like they can, it takes them longer, or like there's some kind of SLA about how much time they have to give you to with liquidity, or they have to, I don't know. But it's sort of a tricky problem. But ultimately,
yeah, I would appreciate if we can discuss it in much more details. Yeah, I mean, now we have a small email thread. Just in case, the second part for Plasma Debit as how do you want to proceed the transactions? So do you want signatures from both parties, which is virtually an atomic exchange, or just one party states that I want to transfer some amount from my coin to another coin, and that's enough? Because in different cases, we have different problems of, for example, receiving to transfer in the same block.
Receiving what?
If the user wants to receive two transfers in the same block, I don't see a good procedure how we can prove the validity.
That's a good point. And this is exactly what I've been thinking about, is both sort of the advantages and disadvantages of like additional things you can do if you have a receiver doesn't need to sign off on a particular receive. So in the very specific case of, so first, I think in Plasma Cash, it's very important generally, and in MVP, to figure out the problem of sort of atomic transactions that involve multiple UTXOs, or in Plasma Cash that involve multiple coins. So even if you have only like an ERC 721 non-fungible exchange, hey, if it's an exchange, then someone's going to need to be trading you. Someone's giving something and getting something else. So it's not just a transfer of one thing. So that you need an atomic transaction. And if it's a normal Plasma Cash chain, forget Plasma Debit, and you want to be able to use change. If you want to pay somebody 2 ETH by giving them a 5 and taking a 3 from them, in addition to all sort of the already existing complications of that, you have to do it as a that's going to need to look like an atomic transaction. And so what Carl and I, at least I think currently still think, is that it's very difficult to handle limbo exits safely, and sort of at least in keeping the exact same properties that Plasma Cash normally has, and applying them to atomic transactions is probably impossible. I think there's ways to do it that, like, they sort of minimize the potential costs. Like, yeah, you may have to do an on-chain transaction to preserve safety, but like you're not going to lose a deposit. It's just ultimately like it is what it is. And so, you may need to do an on-chain transaction to preserve safety without receiving a security bond, a reward for it. So like we thought that we could do that in Plasma Cash generally, but I think with atomic transactions it becomes hard. With Plasma Debit, particularly under the assumption that the operator is the one intermediating all the trades, you have this interesting property where you can basically always resolve sort of a lot of these kinds of disputes anyway against the operator, because we know they're able to block like any transaction they want. They have total data availability. So given that we know this about the operator, I think we can do a little better than atomic things. So that's one, is that if the operator is the intermediary, then you can get interesting additional properties. The other is that if you're doing just pure payments, not not a normal atomic transfers, like both parties really care about the other. Like, Alice and Bob are trading whatever CryptoKitties for ETH. Alice needs the ETH. Bob needs the CryptoKitties. They need both. Each of them needs the other one to happen. if it's a pure like just payment where it's just Alice's money is going down and Bob's money is going up, Bob doesn't care whether Alice's money goes down. Bob just cares about Bob's balance increasing. Bob doesn't, that part of the transaction doesn't need to be dependent on the other. It's actually just like a one-way dependency rather than this mutual dependency. And so I think you can do better in terms of liberal exit state availability there. And then there was one more piece I think you mentioned, right, which is because you're incrementing the balance of one of these accounts, it's not clear that that party needs to be online or needs to consent to it. And that, I think you can get really interesting properties, and that was one thing I want to talk about today. So fantastic segue there. But yeah, I think there's sort of interesting trade-offs there. It's certainly, for example, if the party doesn't have to consent to having their balance incremented, then, well, yeah, we can get into it. Yeah, but I think, right, it's resolving conflicts when you want multiple payments coming to the same one. Again, you can usually have like the operator try to figure out how to thread those. But I think it's sort of it leaves this new set of challenges that we're not used to in a Plasma context. Obviously, in like the sort of on Ethereum or in Bitcoin, you can send to anyone. Without them being sort of online. So I think it's an interesting new sort of wrinkle to this. But yeah.
Okay, yeah, looks like in this case I will have to take additional week to more or less formalize what sites I have, and we can figure it out. So for now, I would say let's allow other people to talk, since we already taken like 15 minutes. Sorry.
Yeah. No, absolutely. But I think thanks for the opportunity talking with you, and we have an email thread. So. Yeah.
Cool. You want to go further on the thing that you were talking about?
Yeah. So I would definitely, So this is something that I've been thinking about and chatting with Kelvin a little about. This is sort of as something that I don't have a name yet, but in my desire, really have a name yet, but in my desire to just stake out basically every piece of Plasma namespacing, maybe we can call Plasma Wire, because it's sort of maybe like a wire transfer. So this is an idea, and it's part of the project of thinking about Plasma Debit from the perspective of how do we fix the flaws in sort of Lightning Network or Raiden Network style multi-hop HTLC payment based payment channel networks. And so in those kind of networks, there's a couple problems. One is that you're not able to transfer a channel from one party to another. So in order to do a transaction, in order to join the Lightning Network, you have to do it. Like if you as a party want to be involved, you have to do an on-chain transaction. And so Plasma avoids that. Plasma in a particular way that it still gives you all the advantages of Lightning. So that's one. And the other one, another one is sort of atomicity. And I think one thing that I may miss without HTLCs, but I think it's not necessarily that clear why do you necessarily want to avoid HTLCs? And so I've been thinking more about exactly how to phrase this advantage and how to really take advantage of it and leverage it. And one way is one of the problems with limitations of Lightning is that you have to be online to receive a payment, and that's because you have to generate this hash preimage, and you have to be the only one who knows it. And you have to sign off on your state channel update in order to actually to receive it. So in multiple ways, I think you have to be online as the ultimate recipient of a Lightning network payment, and that's kind of unfortunate if you're a business or a user, and you don't necessarily have an always online node, but you want someone to be able to manage this for you without to manage the onlineness for you without you being without being able to steal your money. And another problem, so it's a second problem that I'm trying to address in Lightning is this sort of capital lockup requirement, where there's not only does the capital have to be locked up for this fixed period of time, but the number of, for each hop in the payment, you add an additional week or whatever, it's going to be 3 days, 3 hours to the finality time of the HTLC. So the more hops a payment takes, the longer it ends up, the capital lockup ends up being quadratic. Higher.
But in Ethereum, we can use the sprites construction to avoid this.
So sprites already solves this, and what Plasma Wire, what I'm thinking about for that is it basically combines the sprites construction with Plasma Debit, And what it gives you by doing that, I'm sorry?
Maybe we should also like kind of mention what sprites is for people who are not familiar. You want
Yeah, some. I mean, I've sort of read the paper and I've been sort of like noodling on these.
Okay, so instead of like my screen. So in Plasma, in Lightning, the HTLCs, they open, then it goes to the next one and to the next one and the next one, and then they unlock all the funds. Instead, in Sprites, basically you have a global view where you have a pre-image manager contract, and the last guy in the chain just publishes the pre-image, and at that moment, everybody knows the pre-image that's needed to unlock all the HTLCs.
Right.
And instead of like doing linearly with a number of hops, you do it in one step.
Right, and it is recorded on the chain that it was revealed at this particular time. So you can then use that to when you settle your channel to sort of say like, here's how this HTLC shook out. Either it was revealed on chain within this time, or or recounted as timed out. And so yes, that's exactly right. So what that does, it lets you have this sort of this fixed duration. So you end up having linear rather than quadratic capital lockup costs. So the idea of Plasma for doing this in Plasma Debit is that you replace the HTLC manager contract, which is this idea on sort of this contract, the global contract on the Ethereum chain, with the Plasma contract of the ultimate recipient of the payment. And for each step, instead of saying this payment will be, complete this portion of payment if and only if this preimage is revealed, which is kind of this arbitrary sort of like cryptoeconomic condition that we invented in order to serve this purpose. You say just this portion of the payment will complete if and only if the actual ultimate final payment happens on the Plasma on that Plasma Debit chain.
But that requires an on-chain transaction. Right.
In the unhappy case, it does. When you settle, but so does Sprites, because Sprites is the on-chain transaction is we reveal the hash preimage. In this construction, the on-chain transaction is we prove using the Plasma Debit chain and using an interactive protocol that this payment happened. And so what generally with Plasma Debit, one big thing Plasma Debit gives you is the ability to prove to a third party that a payment happened. And you can do that off-chain by proving to by just providing the whole history of the chain, right? In the same way you would do it if you make a payment to someone on it, if you transfer a channel to someone, you give them the whole history. In this case, I prove this payment to you by showing the whole history of this coin and showing that it's valid. So you can do that off-chain. And then if you need to challenge it on-chain, you do it by having a new method on the Plasma Debit contract that is like prove, and it's to prove a particular transaction. So this isn't the same as withdrawing. You can't challenge it. It doesn't require the signature of that party. It doesn't, it can't be challenged by a subsequent spend of that coin. What you're trying to do is just prove that this transaction happened. And so by doing that, now when I'm like an early party in this chain, I know to complete my portion of this multi-hop payment, because you show me the off-chain proof of the entire history of this Plasma Debit coin or channel, and I see the payment that I was looking for happen there. And if somebody, I do this transfer, and if somebody challenges me and says like, no, I don't believe that payment happened, and I need to settle this on chain, I can now do that by having the Plasma Debit contract prove it. And by revealing, I'm like, here's the transaction, and anyone can challenge by saying, no, here's a prior invalid transaction. But they won't be, but you can't like you normally can challenge by showing a later coin, because all I'm trying to do is prove that it happened. And so what we do is it's in some ways sort of simpler maybe to think about than HTLCs and Sprites. It's literally saying just like every step in the payment chain only happens if the final step happens, because that's what everyone really cares about. Is if the final step happens, then we can do all the rest of these. And so yes, you get sort of the advantages of Sprites. It's not like a simpler construction necessarily mechanically, but in some ways it's more intuitive, because it's everybody basically just goes to the Plasma Debit contract and just like looks up. They look up like and they just say like, okay, I see that the payment happened, and I know because it's a Plasma chain. I know even off chain without the interactive online proof that this whole history is valid and that this payment counts. And so so that's a way to. So it gives you the advantages of Sprites, and it also lets someone receive, ultimately the important part about this, it lets you receive payments when you're offline, because only the Plasma chain operator needs to be online, and they're still not able to steal your payment. They just are able to make the payment to you on the chain. Yeah, so this is one reason why I'm thinking the ability to receive payments while offline on a Plasma chain is the ability to receive a payment without your signature, without the party signature, is a useful thing in Plasma Cash chain.
So two things. Firstly, I think I'll need to rewatch the recording to reiterate on this. And do you have any notes that you want to share?
I haven't published it yet. Yeah, so I usually find, I think, that wasting everyone's time with it before I publish it helps me think about it better. So thank you, everyone.
Yeah. So okay, interesting.
Dan, what is the proof? Do you send the whole Plasma Cash proof and then the proof of every transaction in the payment channel as well?
Offline, so the offline proof you're talking about, right?
Yes, the offline proof.
Yeah, the offline proof is just the Plasma Cash, the normal Plasma Cash proof of showing the entire history of,
Okay.
Which should be able to be combined with checkpointing to provide less blocks.
With what, sorry?
With checkpointing of coins.
Naturally. And yeah, I think that the typical sort of Plasma Cash proof. And this again is taking advantage of the general advantage of Plasma and Plasma Cash is that you can prove to a third party the existence of a transaction that isn't, and the proof of non-conflict there because of the headers being committed to the main chain.
Cool. Georgios, do you have?
Well, I want to discuss a bit about Plasma XT, but perhaps we have Gnosis first time on the call, and we have taken a bunch of time, so I'll give them my slot. Yeah, please go ahead.
Yeah. That's so kind. Awesome. Thank you. So we have written this paper and it's very long and hard to understand. So what we would like to do in Plasma Call, just give an idea of what we want to build. And then of course we are looking for the feedback. No other company I think has done something like this. So would it be okay if we give like a very short presentation of what we want to build and then later on collect the feedback? Yeah, okay.
Thank you, Calvin. Exactly.
By the way, guys, should we make some kind of Plasma meeting in a DevCon?
Okay. So I have a thing that I want to quickly discuss on that topic. Because yes. So what I've wanted to do recently is get this sort of Plasma working group started. So there's a bunch of people who want to do Plasma research, obviously, and sort of not enough researchers to go around. But the in-person stuff is kind of the best work environment. And so I want to do these occasional sort of meetups where people get together in a single place for maybe a week or two, depending on how people feel about that and what the schedules are like. And I wanted to do one after DevCon, since it made sense, or either before or after DevCon, if everyone was already going to be in the same place. So let me know how you feel about that, and I'll try to organize it.
Maybe after, so that everybody has presented their material, they got feedback for their presentations, and then they start working on stuff.
Okay. Yeah,
I'd also say after.
Cool. So if people feel good about that, we can organize that.
Cool. Yeah. Cool. That sounds awesome.
Oh, Georgios, you can continue while we wait for Gnosis. Well, all right. We have some time, yeah.
So wait, let me just get my paper notes out. Yeah, okay, so paper notes. Yeah, old school. So basically I did a call with Kelvin some days ago, and we talked about how like the protocol for Plasma XT would work. And basically there's so the process is like that the operator starts advertising that they want to make a checkpoint. So I'm just saying my understanding right now, and let's have a short discussion on this. So the operator, let's say that they say that, okay, now I'm just gathering signatures in order to start the checkpoint for coins 1 to 3. Users send a signature, a commitment a signed commitment to the operator, and they tell him, okay, please checkpoint my coin. And then the operator creates a Merkle tree from all this, which is an attestation of their addresses that they own this coin. And then the operator makes a commitment to that checkpoint with the block number, the bitmap that forms this, and the state root, which is taken from the coins that were signed on. And then there's the usual challenge period, and after some time, there's the finalized checkpoint, whatever. And after a checkpoint has been finalized, the coins that are governed by this checkpoint, they are considered checkpointed. And now, when the off-chain transfer happens, a user does not need to check for after a certain point, for before that coin's checkpoint. So that is the happy case. I believe we agree on this part. Kelvin, you also agree?
Yeah. One small change at the very beginning of the protocol. So you have one basically request to checkpoint, and this is annoying. So be warned. So you have to have a request to checkpoint, and then the operator has to create this state tree, and then send the actual state tree. Send the pathway.
The Merkle paths, yeah, I missed that part, right? So the users will only provide the signed commitment if they are provided a Merkle branch that proves that the operator actually constructed and published a root that validates that checkpoints their coin.
Correct. So they don't need to worry about anybody else's coin. They just need to see their own paths.
Yep.
But they do need to see the actual paths.
But I'm not sure. So is it always better instead of publishing the whole? Yeah, it is. Okay, giving the Merkle trees, because I imagine that the operator can just publish the whole Merkle tree. Imagine that if we have like all the users, the operator needs to send. Maybe the data needed to send all the branches for all the coins. It's more than just publishing the whole tree. I'm not. So is it the same?
Well, your tree is sparse, so maybe you can get away with the size. Otherwise, how deep do you want to make a tree? 16 is okay. 32 is already at least something like 100 gigabytes if you publish everything, and it's not too sparse. So it's just too much.
No, but the tree isn't for the entire. The state tree doesn't have to talk about the entire Plasma Cash tree. It only needs to talk about a small subset. What you can do to avoid one initial step at the beginning is have the operator assume that everybody will want to checkpoint their coins and just make what they believe to be a valid state tree. And then just there should be a period at the end where people request a certain branch. They'll receive the branch and then they'll sign it. So the operator will already have created the state tree at that point. So that's fine. That avoids another.
Yeah, but that's an optimization in the protocol. So
yeah, optimization. It just means you don't have to request and then later receive some.
You assume that there is a checkpoint. You assume that everybody wants a checkpoint because why not?
Yeah.
And if somebody does not, okay. So that is the happy case that I just said. And we have a point, and now somebody that and that checkpoint. Let's say that Alice owns a coin, but the checkpoint is an attestation that Bob actually owns the coin. So it's some kind of collusion between the operator and Bob. So Alice sees this and she provides some kind of, she actually provides proof that she owns the coin, that she has the latest transaction or some transaction of the coin at a previous block from the block that is to be checkpointed. So, which is very similar to the challenge with an invalid exit history, with an invalid history, where some coin has just been generated after some invalid block. Okay, so the challenge happens, and the challenger, since it's an interactive challenge, also provides some bond for this. And what needs to be done now is, from our discussion, that there are two kinds of responses in this. Firstly, the one kind of response is the usual one where you respond to an invalid history challenge with just with an immediate spend of that coin that shows that you no longer own that coin, so you don't have the right to challenge. While the other way to challenge is by revealing a signature that that you actually consented to your coin being challenged by somebody else. So I get how this would work, how this would be implemented. However, I do not get when it would actually happen. So, because if I have provided, so did that make sense to everyone? How I phrased it, or should I rephrase it?
Yes. So when that second challenge would happen?
Yes. So why is this challenge of revealing a signature necessary? Yes.
So the case in which this is necessary is that the operator or whoever makes the checkpoint puts a 1 in the bitmap for your coin. Right? So they claim to have a signature.
Yes, but why is this not desired?
Because if they claim to have a signature, then that checkpoint becomes valid after some period of time.
Mm-hmm.
Right? It becomes the history. So if they put an invalid owner, let's say, for your coin.
So in the case of an invalid owner, I believe that is how that is challenged by revealing a spend. No.
No, invalid owner as in I put myself, maybe I'm the operator and I put myself as owning your coin.
Yeah, yeah, and I challenge this by requesting that you either provide a spend, so you respond to my challenge, so I attest that I own the coin, while the checkpoint says that you own the coin, and then I make a challenge where I say no, I own the coin, and this is the latest proof. And in order for you
might not know the checkpoint. That's the idea. That you as the challenger might not have data availability over the checkpoint. So you don't even know, maybe I'm the operator and I'm hiding the contents of the state tree to you, from you, right? So you don't know if I've made you the correct owner or not. Maybe I did make you the correct owner in this state tree that I've hidden. And
okay, so this contradicts the fact that the challenge has to provide the adequate information about who owns the coin. So when I make the challenge, I do not really need to provide information that I actually own the coin. I just make a request from you to provide the signature. And if you don't provide the signature, okay.
You do need to show that you own the coin, because the signature...
But how do I show that I own the coin if I don't have data availability?
You have data availability over your own coin. So you present the latest transaction in your history, and it's because the signature has to correspond to the latest owner. And so if you didn't have this, then the operator could just reveal a random signature and say, well, this is the latest owner. So you're basically claiming, I claim to be the latest owner, and I claim that you do not have a signature from me. And so that's two separate claims. And so one challenge is challenging the first claim that I'm the owner. And the second challenge is challenging the second claim that I didn't sign a signature. So those are your two cases, really. But you need to prove that you are the latest owner. Otherwise, the operator can just provide a random signature.
Okay. So the first response is that, okay, it breaks the attestation that you're no longer the owner. And the other attestation is that you haven't signed that checkpoint. Okay, so the first one, okay, right. So the first one basically invalidates my challenge, and the second one, it also invalidates the challenge, but invalidates the part that of the checkpoint construction. It invalidates my doubts on the checkpoint construction.
Right. Yeah, it just reveals...
I'm just trying to get this in words to be better digested, if you will.
Yeah.
Okay. All right. Yeah, that answers my questions.
Cool. Is Gnosis has a gun?
Yes, we are back in the game. I don't know, like what happened. Probably my computer got too hot because in Berlin it's crazy hot, and yeah, somehow Zoom crashed. Never happened to me before. But yeah, let's try the sharing again. This time with another computer, with Macs. Usually I don't work with Macs. Let's see what this looks out. So you guys can see my screen, right? Let's maybe get rid of this one. This one. So good. So we want to do batch auctions on Plasma. Basically, we want to build a decentralized exchange. And first, I want to very roughly describe of what we actually want to build. We'll very quickly go through what is a batch auction and how we imagine to build it. And then we're coming to the interesting part, like how to do that on Plasma. So a batch auction. So can they see my full screen? Probably not, right? They might only see my present.
If you hit %, it should be good.
Perfect. So just very quickly, what's a batch auction? Probably you all know it. We collect orders over a longer time period, like that you want to buy some token A for token B and vice versa orders. And then we're getting these order books. You all know them. The only difference to the usual order books is that there's this overlap of the orders, buy orders and sell orders. And then we are calculating an optimal price for this batch, meaning the price that optimizes the trading volume. It's here indicated with red line. And then we can all settle these orders with this red line. This is basically just what a batch is. And another concept that we're using is ring trades. So if you have, again, token A and token B, and there's a sell order, token A for token B, but no order that goes in the other direction, then usually you cannot settle anything. But if it happens that we have also a sell order from B to C and a sell order from C to A, then we can basically. These are kind of two concepts that we're using, and what we are doing with that, we want to build multi-dimensional order books. So I want to explain it very quickly with the concept over here with 3 tokens, token A, B, and C, and between each of these tokens, we have these overlapping order books. And now we want to find a price between all these tokens so that we're overall getting the best trading volume, best trader welfare. So for that, we are taking this diagram. On the axes are the prices A versus B, prices C versus A, and prices C versus B. And then each point in this diagram represents one set of prices, and then for each point we calculate what is the trading volume. And we are interested in the one which maximizes the trading volume, because then what you're basically doing, you're executing all ring trades at the best possible price. And yeah, we're super excited about this mechanism. We think it has lots of benefits, and we want to build something like this on Plasma. So how it works very roughly, we can trade any token against any other tokens. We would collect on a Plasma chain maybe for 3 minutes orders. And then we would calculate this uniform clearing prices, which I mentioned before, basically the price that maximizes the trading volume, but it also needs to satisfy constant constraints, for example, that it's arbitrage free, and that the amount of tokens sold equals the amount of tokens bought in auction for each token. And then once we have the price, we can all settle them on the Plasma. This is very roughly what we want to build. And now we found a specification which we think enables kind of these key features. So that we have a batch time in 3 minutes, that we can roughly process 60,000 orders, and probably roughly 100 transactions per second's capacity. We want to build that on the Plasma minimal viable product. We love the construction of the more viable Plasma, but we think we need aggregated signatures anyways. So we anyways need to have some kind of double signing mechanism, and then we chose that the MVP would be easier. Yeah, of course, since we're trading on Plasma, all the gas costs are heavily reduced. So very roughly, this is now the rough concept, and the next slide we will go into the details. So we want to collect the orders over 3 minutes, then the operator finalizes the orders by putting them all in an order book block indicated over here. We are calculating the hash. The hash is submitted to the root chain as it was with all the transaction blocks as well. Then the operator calculates these prices, trading volumes, and the trading outputs. He needs to supply some proofs that this was all done correctly. And then we can settle them and go on with the next options, so that we can really schedule one auction after the other. And now I want to go there a little bit more in detail about how that actually works.
I think your slides are not changing for some strange reason.
So what can you guys see?
Move the dimensional order books.
Yeah.
Stuck in this for 2 minutes, or yeah.
Stuck for at least 2 minutes.
1.
Yeah, the main question so far is, are those optimal prices even provable or challengeable on the mainnet?
Yes, I will explain it just in a second. The operator needs to prove some things about the prices. For example, that they all fulfill the constraints, that they are arbitrage free, and so on. And for this, we will generate a snark proof that the operator then first only publishes to everyone, but people can request it on the main chain.
Cool. Maybe re-share your screen.
Can you now, what can you now see?
Yeah, it's still, like, we can see your mouse moving around and it looks like it's...
And in the chat, Kelvin send a link. The short plasma exchange batch auctions has the presentation also.
Yeah, thank you for, just for a curiosity of someone who's working for like a snarky plasma, how many constraints do you plan?
Yes, there will definitely be quite some constraints there. We have some small doubts that we will manage to generate the proof very quickly, but we have a good way in the protocol that allows us to delay the proof generation a little bit, and with that we can even make proofs for higher amounts of circuits. So guys, you need to help me very quickly. What exactly can you now see on the screen? Can you see auctions with Plasma MVP and the...
You cannot, no.
Nothing has changed. Can you try exiting and...
Yeah, exit and re-enter, exactly.
Every conference call.
For real. Great.
Now you can see it?
Yep.
Okay. So now I want to explain how that works all a little bit more in detail. So on the top, definitely we have the Ethereum root chain, and on the bottom, the Plasma chain, where there are already some transaction blocks. And then in one of these transaction blocks, we will publish a DKG public key. And this key will be used in order to encrypt our orders. And the good thing is that we are using DKG in the sense that the private key is not known to the participants, only the public key. So first this key is shared, then everyone can encrypt all their orders and send it over to the operator. And then the operator generates an order block. And in this order block, there are all the orders. And then within the Plasma MVP, we have always the notion of double signing, and now we need to make sure that all these orders are also double signed. And we want them to be double signed with an aggregated signature, basically what you guys talked about just before for the checkpoints. It's exactly the same technology. So everyone hands in his signature, yes, I want to participate in the next batch with these orders and this my order block, and then he signs this message, sends it over to the operator, and he then generates this bitmap with the aggregated signature. And once this is done, or before that it was done, like no censoring of any orders could happen because the orders were encrypted. But now, of course, we need to decrypt all the orders. And for that, the DKG participants, they're coming together and then generate this private key. So now the orders can be all decrypted and the operator can calculate some prices. And he also needs to calculate some proofs, snark proofs that prices are fulfilling some constraints, as I said, for example, that they're arbitrage free, that no tokens are generated out of nowhere. And he needs to submit all the volumes, like for each order, with how much volume it was traded in the auction. Then he creates all the auction outputs. That's basically just the settlement of the whole batch auction, and then the next one can go on. And we are convinced that this all works because if something is happening before the double signing procedure, if there's anything wrong with it, then people would just not double sign. And if anything goes wrong after the double signing procedure, then we have put all the information in a very compact manner so that they can upload it onto the Ethereum root chain. And over there, we can then settle all the ones. So for example, we would need to know which orders are participating in the batch, and we basically know it with a bitmap. We can also publish all the prices and that the prices are calculated correctly, and also which volumes are participating in this auction. So these are kind of the most important information, and they are very easy to upload on the Ethereum root chain. And so if the operator does something malicious after the double signature, we can enforce the trades via Plasma Excel.
So, are you done?
No, we are not gone. But this is kind of the whole idea of what we want to build.
I have a question. So how are users able to, if somebody at the double signing stage signs to something that was not like legit, how do the users complain about this? Do you use the classic like Plasma challenge constructions, or is something else needed?
What exactly are you asking for? Like if the bitmap is not?
Yeah,
or if,
let's say that if the bitmap, for example, is not correct. So I made a trade and it got censored, for example.
So if the bitmap is not correct, then we can easily upload the bitmap on the Ethereum root chain and then challenge it over there exactly as we challenge checkpoints in Plasma checkpointing. What is it called? Plasma XT, right?
So quick question on this. So you have the double signing phase. So the owner, or sorry, the user that created each order has to double sign.
Yes, exactly.
And so, sorry, the orders are encrypted, and does the operator have access to the decrypted orders?
No, only later on once the DKG private key is generated.
So how do you know which public key corresponds to each encrypted? How do you know that the second signature actually corresponds to the user that created the order in the encrypted order?
So in the orders, not everything is encrypted. Basically, just the limit price and against which token you want to trade.
Okay, so you can still censor from a specific user. You can say block all orders by some user.
Yes, you can do that, definitely.
Okay.
For the parties who generate the DKG, I mean, if one of those later declines to participate in revealing the private keys, then the round is non-valid.
Exactly. For this, for the DKG, you can do it with the threshold. For example, if you have 100 DKG participants, that 80 of them need to participate. And if 21 then say we do not want to publish it later on, then you can kind of punish them also or slash them on the Ethereum root chain for not revealing it. Definitely, if this threshold is then not met, then we kind of need to restart the whole auction.
Is it correct to say that due to how all transactions are settled, so my understanding is that per batch, all the transactions at the end, they are settled at the same price. So does this mitigate the risk of front running, which exists, for example, in dexes with order books that are off-chain?
Yes, we think it's even a fairer price if you batch these things together. So we think mainly this is the main advantage, that they are fairer prices, that you can atomic trades, but definitely also it would already help a little bit with the front running, but still if you do not have the DKG at all, then front running is still a small issue because people could sneak into the auction like in the last second if the auction is favorable in some way for them. And also the operator could censor some meaningful transaction in order to get some specific prices, which is kind of similar to front running a little bit.
Yeah, that's what I thought. So maybe the operator at some point they start censoring everything, and that prevents them from that prevents the asset being traded to reach its fair price. Because basically the operator said, okay, I will make this much money and at this price level, and it's fair for me. Does this make sense? So is this a danger, you think, or is this allowed, basically? That's my question, essentially.
If EKG works very well, the operator cannot censor anything because he simply does not know very well what these orders are exactly for. He can,
well, yeah, I wanted to answer George's question. Well, basically, if an operator commits to the full block of orders before revealing the private key of the DKG, an operator, well, may know what's inside from users, but doesn't know what's inside in terms of what token and what volume and what limit price. So you more unlikely to win in this case. So you cannot censor as this part. You can only censor the user completely, but not censor the particular prices or orders.
Yeah, you could probably do some like side analysis of, you know, what kind of trades are certain users making and strategically censor users to get prices that might statistically be preferable to you. But I'm sure you could also, as a user, change your behavior to mitigate that. So I'm sure it's, for the most part, I would say it's more difficult. You can't just censor strategically outright. You would have to do some math on top of it.
Yes, definitely.
DKG, the verification needs to be done on chain, right? Do we have it? Is there a way to do this right now in Solidity?
Which verification? The snark proofs verification?
Any kind of non-trivial verification. I'm not sure, like, so yeah. So I'm not very familiar with how DKG works. That's why I'm making this question.
Yes. Yeah, at the end, the DKG is just a private public key pair, so it's fine. Yeah, the problem with generation it is a separate issue. But if you commit to some generated DKG and then you later reveal the private part, which doesn't match, it's almost trivial to check that you reveal some trash.
Exactly, like with DKG, most of it is really happening off-chain. The only thing later on you need to make sure is that the private key belongs to the public key, and this you can do on the blockchain. And with the snark proofs, it's that there is this nice framework Socrates, and with it shows it is a nice environment where people are able to generate these proofs and then also put them into a Solidity contract. And this can be then later on run for, I don't know, it depends on the input, something about 1 million gas. Cool. Any other questions?
Yeah, I just think that the amount of information is quite large. Maybe some better feedback will be in some thread on its research. If you already posted it, if not, just let everyone have a look at it.
Yeah.
My concern is the proof of this block of aggregated orders, which were encrypted by only revealing the commitment to them and the fair prices, is just enormous. I mean, it's what I do for trying to construct the plasma for using the snarks to prove the state transition. But this is just a part which is the most difficult to overcome, unfortunately. Yeah, I mean, if you want to discuss it later, you could just discuss it separately. But yeah, otherwise it looks very interesting. And I sent a link about some kind of well, with a paper from economics, which was once sent to me, about how you can make matching on a traditional exchange with much slower time frame. Maybe you could use this to calculate the fair price in your proof. I don't know if you ever read it.
Yes, we will definitely take another look into it. Cool. Thanks for sharing. And yes, with the snark proofs, that's definitely our one of our main concerns right now. But as mentioned before, because we think that we can generate these proofs in a much longer time frame, we hope that we find a good solution over there. And like these days, there's so many technologies going on, like people are using different hash functions and whatnot. Yeah, we are looking into it. And even if it does not work, we can also apply the same specification and just do a true-bit game and checking with the true-bit game the constraints instead of doing it with snarks.
Have you thought of doing this on Plasma Cash?
It's like, yes, we thought about it, and we also thought about doing it with the more viable. But for Plasma Cash, like you basically put a lot of money into a pot, and then later on you have to split it after the auction. And this requires a lot of splits, and we thought that probably with Plasma Cash, that's not the easy solution.
But you can probably modify the exit game so that you just have a list of participants in the auction, and during the exit you just do the distribution, the settlement that way. And also you wouldn't have, I believe that you wouldn't have the history, let's say the checkpointing issue that we tried to solve. You wouldn't have this in your issue, because per batch, it's like per batch you start a new Plasma Cash chain. It's like that, because nothing, I understand that batches are unrelated to each other. So you would have like a certain compact history, let's say.
Of course, you can also use just any output from like some very long time ago transaction and use that as an input for an order for the next batch. So they're not completely separated, I would say. But yeah, we'll also investigate on that more definitely. If you have their ideas, let us know. Type them down, and eat research would be awesome.
And at the end, this is like a big atomic swap, like between like multiple parties. Is that correct to say? Like during the final settlement?
No, I wouldn't use the word atomic, like a swap definitely, but atomic, I would not say, because we're really trading like a whole bunch of coins for the other ones, and we're not splitting them up into these small pieces.
But they all change hands in the same step.
Yeah.
Yes. Yeah, I think that the George just means that either everything happens or nothing happens.
Exactly. That's right.
Cool.
Carl, it's your turn.
It's my turn. Okay, well, my turn is I am going to be giving a presentation at the Decentralized Web Summit on Plasma and crypto economics. That study, of course. I mean, come on, who am I? And so for this presentation, I need to take an Uber and head over there. So I guess are there any final things? I guess we're pretty good. Well, thank you everyone for yet another amazing thing, and welcome Gnosis to the call.
And thank you for the very elaborate presentation.
Yeah.
2,000 slides.
Guys.
Oh, no, I'm talking about Gnosis. I'm talking
Gnosis. Gnosis. Yeah. Gnosis. That one too.
Yeah, Carl failed to mention that his presentation is 2,000 slides long.
Yeah. And then it just
did he generate it?
I'm not joking. It's actually like a Google Slides presentation with 2,000 slides.
It's public. I'll put it in the show notes. All right. See everyone.
Okay, see everyone. Have a good day. Good morning or evening.